All right, so what we're going to look at is reducing balance loans. So what we're going to see with a reducing balance loan, it's with compound interest. So this compound interest is the growth, yeah? It's what you have to pay the bank for borrowing the money, okay? And then it reduces by making, and it's reduced in value by making regular payments. So this is what we would call the decay, okay? So you can see here down in our recurrence formula, so you can see that this D value here is the decay, and what we're going to say, which is the payments you make, the payments of the loan, okay? So you can't just borrow the money without paying the bank back. So here's that's the payment, and you can see here this R value is going to be the growth and pretty much the interest you're paying the bank. Okay, paying the bank. All right, so off we go. So we can set up a recurrence relation that like that for a reducing balance loan scenario. So once again, you're going to see we're going to work out the this capital R value by using our interest rate. So you might write over here, remember that R is going to be the percent, is going to equal the percentage per annum, percentage rate per annum, and we're going to also, we should probably have PPY in there now. So PPY is the compounds per year. So in 1 year, how many times do you charge the interest? And obviously D is the payments made. So they'll tell you what payments you're going to make, and VO is your initial borrowing, initial loan amount you might write. Okay, so as we said, if we've got a reducing balance loan, you'll see a curved line. Just, it's not very obvious there, but just write that's a curved line, yeah, for a reducing balance loan. Because as you slowly pay it off, your payments will take a bigger chunk of it, hopefully. So a lot of this is, it comes way more clearer once you do actual questions. So as I said, on your cheat sheet, we have a reducing balance depreciation. So this is when you have the loan. Sorry, we had the wrong loan, so we found the right one on our formula sheet. So it's the reducing balance loan one. Okay, so Alyssa borrows $1,000 at an interest rate of 15% per annum compounding monthly. She will pay the loan, making 4 monthly payments of $257. The recurrence relation to model the loan is in the form of this, which is what we would like to see anyway. So that's the way we would set it up. So they want you to do this in a recurrence relation. So you've got to write your VO. So that's initially what she borrowed up here was 1,000. Sorry. We need to work out, you can see we've got to work out this R value in here. So we'll just do it over the side. So up here, if we look in our formula sheet, it's telling me how to do it. So R is 1 plus the rate over PPY over 100. So in this example, it'd be 1 plus, now the rate is 15, and the PPY is 12 because it's compounding monthly and there's 12 months in the year. So we do that. Okay, so I get 1.0125, so that's my R. So when I come over here and I go to write the recurrence relation, you can see I've got to write Vn plus 1 equals R, which I'm going to change to 1.0125. Then you're going to times it by the one before. Then you're going to minus this D. And the D is, if you look over in the notes, is the payments that you're making. And they did tell you that. All right, so you've got to minus the payment. Now, they told me the payment here. So this is that D value. So you just say minus 257.85. Okay, because they told you what the loan payments are. All right, so that's simply setting that up as a recurrence relation. So they will pay $257.85 every month until it's paid off. Yep. Okay. Okay, so let's have a look at this. Alyssa's loan can be modelled by the recurrence relation here. Use your calculator to determine recursively the balance of the loan after Alyssa has made 4 payments. So it's just doing like what we have been doing before, where you would just write VO equals 1,000, and you have to show the next 4 payments. So V1 would be 1.0125 times 1,000 minus 257.85, and you'll get an answer. And then we're going to say V2 is 1.0125 times that answer. So I better work that out. Okay, so we kept doing that, and you can see we take the answer from before and you pop it into the formula and you keep going. So you do it recursively on your calculator. When I was actually writing the writing out, I've rounded the answers there. But you just keep doing it on your recursively on your calculator until you get to the one they said 4, because this is how the banks will work. And you can see after 4 payments, she was supposed to have that loan paid off. But you can see here, there is still 4 cents there. And that means there's 4 cents owing still on the loan. So, because what happens is we start rounding and the bank, and even though when we rounded her payments, when they worked it out, so they rounded it, but it didn't quite cover it. So, you know, when you got to 257.85, the payment. So what happens is you adjust your last payment. So what she paid, this is what she paid in the last month. So she paid this amount on the last month. So on the 4th month. And what you're going to do, because at the end of that she still owes 4 cents, the bank does not want to carry on and charge, you know, for 4 cents and go and do the interest. They want to tidy it up. They want the loan finished. So what happens is that 4 cents gets added to the last payment. So her last payment is going to be the 254.71 plus the 0.04. So her last payment, oh yeah, sorry, I've written the wrong number. Yeah, sorry, the payment here. This is the payment, yeah. So you're gonna add 4 cents to that one. So you got your 257.85, you're gonna add 4. So her 4th month payment is actually going to be 257.89. So what happens, do you think, when you get to the end of if you had a plan and they said 4 months and that was a negative number there? That means she's paid a little bit too much. So you would take that off the payment. Does that make sense? So you've got to start thinking like that now. So if that was negative at the end, that means she paid a little bit too much and you'd have to adjust it that way. Because it was positive, she still owed a little bit more. So what is the balance of the loan? If you go through these questions, we can see that. So B, we saw it was 4 cents. And then it says if the loan is to be fully paid after 4 payments is made, if not, how much should her last payment be? And so we work that out there. That's what her last payment should be. Okay, so we're moving now onto amortization tables. So what they are, to me, they look like they're bank statements. This is what you get on even on your app. You probably might see things like this happening. So they show you what's happening with an amortization. So with a loan, it will show you what's happening after every payment. So with a reducing balance loan, they break it up in terms of here. Like you will then, every month they will show. So when you have the loan of 1,000, you then have to, it gets charged. So this is like that scenario before. So she gets charged interest, and this is the amount of interest getting added. So here you can see, I might just change that to blue. So the blue is the interest being added, because you are borrowing that money, so the bank is charging you. So what the bank is charging you, yeah? Bank charging for the loan. Okay, so then it shows you that. But even here, so here this, and it also will show the payment that you're making. So she set up, this person before, 257 is going to be her payment. So they're saying their payments. So if you think about it, after the first month, you had $1,000. The bank charged you interest. So really, she now owes $1,000 and $12.50. So that would be what her total is. But she's going to make a payment of $257.85. So can you see that her loan does not reduce by that payment fully, because what they do is they minus the interest out of her payment. They're going to say, wait a minute, you pay the interest first, and then we'll drop the loan by whatever's left. So now what's left is only $245. So you can see this number here, I'll just show you. This number here, I'll put it down here in the purple, is 1,000 minus 245.35. Yeah? So this 1,000 minus that gave that one. And that's what you got to work out, because you got to pay what you owe, like that charge bit first, and then they'll drop the loan. So that's what's happening with the amortization table. And you can see here, they adjust it like what we did manually, we saw, and you can see even though her regular payments were normally the same thing, that last one got adjusted by the bank so that it would be 0 at the end of the time they set. So she only wanted to pay it for 4 months, okay? So you got to look at it. The steps there are on the side of going through each, but we'll just go through them and we'll practice. It's a lot of comments. All right, so here we've got an example. A business borrows $1,000 at a rate of 8% per annum. So remember, okay, so we've got the borrowing of 1,000 soils. So that's our VO or whatever. This 8% is our R. So it's 8% per annum. When they say they're going to be they're going to pay it off, but they're doing quarterly payments, that means PPY is 4. They're doing it in quarters. So every quarter. And it just happens that this person's going to pay it off after 4. So after 1 year, they're probably going to pay it off by making these payments. So we've got an amortization table is shown, and they want us to work out the gaps. So if you look at before, I said what we call what the loan is reduced by, that's called principal reduction. So that's the payment minus the interest charged. Okay, so we're going to go and work out. So if we're saying the payment minus the interest equals that. All right, so we could work out what that interest was earned by doing this payment minus that one, couldn't we? And we could work out what the difference is. So let's do. So we got an interest of $200. Okay, so then what would happen is this 10,000 reduced by this amount, and we're on a total of this now. So then the next quarter happens, and we get charged the interest. So we're actually getting charged 2%, because R divided by PPY would be 8 divided by 4. So every month, 2% is the quarter rate. So 2% of this 7,000 ended up being that. So they want me to fill in the principal reduction. So all I have to do is do the payment minus what the interest was. So we can do that one. So we end up with 4.72. Okay. And then here we've got to work out what the balance is. So the balance is always the balance before minus the principal reduction. because that's how much your payment is actually taking off it. So if you do that there, so what we'd be doing for this example, we would be doing 5,099.08 minus this principal reduction, so 2524.22. Okay, and what do we get? Sorry, you get 2574.86, which you can see you should probably, because this person was going to pay it off, it was the total there. But don't be sure, just do it the normal way. Sometimes things change. So you can see that's what's happening there. Okay, the first 3 lines of an amortization table for a reducing balance loan, home loan, are shown below. So this is really important that you know what scenario it is as well, because we use these tables with investments as well. So this is a reducing balance loan. So that means our payments are wanting to decay, reduce the amount. Okay, and we have an interest rate of 4.8% per annum. So when they tell you that, you need to be writing in that they're telling you our little r value, just so you remember. And when they'll tell you compounding monthly, so we know that the PPY is 12. All right, the loan is to be repaid with monthly payments of 1,500. So this is another thing you want to be writing. Maybe we'll just write PMT for payment, so we're aware. So we've got our amortization table that we've been used to seeing now. So the amount of payment number 2 that goes towards reducing the principal of the loan. Pretty much that's just a way of saying they want number 2's principal reduction. So that they want, this is this question here, this one there. So we saw before, if we do the payment minus the interest, that will give us the principal reduction. So we need to work out this interest amount here. We need to work out how much interest went into that thing. So over here, I've written how we will find the interest. So remember, the interest would be calculated on the per annum rate, which is 4.8, but we would divide that by how many times it's happening. So when you're on payment 2, it's happening monthly, so we need to divide it by 12, and then we're going to times it by, divide by 100. So that's like that. That's the interest part. And then what you do is you times it by the balance before. So the balance before means that, when I say that, I mean the loan balance before that, that payment number. So in this example, it'll be 249,500. So when you do that, we'll calculate what the interest is. Okay, so we get it to be 998 is the interest. So that's the interest, but remember the question is the principal reduction. So we do 1,500 minus 998, we get 502. So what is the amount? What's it going to drop by? Is B, 502. Okay, Samuel has a reducing balance loan. So once again, it's important that you know what they're talking about. So a reducing balance loan. And the first 5 lines of the amortization table for Sam's loan are shown below. Interest is calculated monthly. So you know they've given you a little bit of that PPY is 12. And Sam makes monthly payments of 1,600. So there's your payments. And interest is charged on the loan at 3.6 per annum. So they told you the R%. So remember, banks and all that, they will always quote the per annum rate. But he's actually doing it monthly. Okay, so using the values in the amortization table, calculate the principal reduction associated with payment number 3. So they want this amount here. This is that first question. Now we know that is always the payment minus the interest. So we simply just have to go 1,600 minus the 956.15 and we'll get our answer. Okay, so 643.85. Okay, then the next one is calculate the balance of the loan after payment number 4 is made. So they want, this is the question there. So you can see, we know when we work out the balance, first we do, we work out the interest, and we do that the payment minus the interest will equal the principal reduction. And this balance is going to be the balance before minus the principal reduction. So we need to work those things out. So obviously we need to work out the interest, which is here in the green. So just like what we did before, I'm going to work out the interest. So I would do, the way we work out the interest is we take the per annum rate, we divide it by the PPY, which was 12 over 100, and we're going to times it by the balance before. So the balance before was this balance there. So the 318,074.23. So we'll calculate that. Okay, so we work that out to be 954.22. Okay, so we know now in here is 954.22. So we would be working out the principal reduction. So therefore 1600 minus the 954.22 equals, what is that one? 645.78. Yeah. So 645.78. So if we go up to the question, the balance before was 318,074.23 minus this principal reduction, which we've worked out, and we're going to get our balance to the nearest cent. Okay, so that ended up being 317,428.45. Okay, so the answer here is 317,428.45. And then the last bit, it says here, is let SN be the balance of loan after N months. So this is, we've all been talking about a monthly. And they want the recurrence relation. So if you go to your cheat sheet and you go to reducing balance loan and you're going to set up the recurrence relation, what you would see is written there is that you have to have VO, which is your principal, then you'll have the VN plus 1, which will be the R times VN minus the payment. So we've calculated, well, let's just go do it. What you would be doing, but you just got to use SN. So SO was 32,000, because I can see up here. So 32,000. And then SN plus 1 equals, you would have worked out that R value, and the R value will be 1 plus the R over PPY over 100. So it would be 1 plus the 3.6 over 12 over 100. So you're going to see this 1.0, what was it? 003. So you can write your formula out. It'll be 1.003 times the one before. Sorry, I went to write V. We want S in this case. Then you go minus the payment, which is 1600. Okay, so this one, it's got an amortization table for a reducing balance loan. So, and you've got monthly repayments. They're just important that you know that PPY is 12 there. Okay, and it says the interest rate for this loan changed immediately before the repayment 28. So what that means is this interest, it said before, so this interest here is going to be at a different interest rate as the one, say, these three. Okay, so they're telling me the blue had a interest rate, oh my God, interest rate of something, and then it changed, and the green had an interest rate, and then it changed to a new interest rate. Okay, so then these two would then have new interest rates. Okay, and it says the change in interest rate is best described. And if you look through the answers here, they're quoting the interest rate per annum. So what we really need to know is we need to know what those two R rates, the per annum rates, were up here. So what I'm going to do is here, I'm going to work out how we calculated this. So say, which one will I pick? I'm going to pick this one here because it's in the blue. So if I look at interest, how do we find interest on an amortization table? It's always done the rate over the PPY over 100 times the balance before. Okay, so this little R, that R is what I'm trying to find out in this scenario. So what I'm going to do is use this interest amount. So I know that amount is 967.08. I don't know what the R is. I know the PPY is 12. And I know the balance before is up here, 230,256.78. Once I get to this point, you can just use solve. Okay, so we'll just use solve, comma, R, and we're going to find out what the interest rate is at the start. Okay, so I get the blue interest rate per annum to be 5.04% per annum. And now I know it changed, so now I've got to find the green interest rate. So the green interest, still using the same formula, but obviously the rate changed. So I need to, so I'm going to use this interest. So I'm going to say 1002.26 equals R. It was still monthly. And I'm going to times the balance before, which is this balance here. So times 22785.76. And you can do the solve again. Okay, and I'm going to find out what R equals in the green scenario. Okay, so I get the rate to be 5.28% per annum. So how has it changed? It went from 5.04 up to 5.28. So what did it do? It increased by 0.248. So that was an increase of 0.24%. That's why we've done that.